Hi everyone, welcome to the second video, and we're going to be continuing to learn new methods of solving systems of equations. This video will describe solving a system of equations by the substitution method. As we've noted before, the graphing method has some limitations, especially if you're trying to do them by hand. You can see here that you have two lines that intersect, but looking at the graph, there's no way to really tell where, because it's very difficult to change the scale of this to see. And then another one is they don't intersect on a corner, so they're in a fraction, so all you'd be doing is guessing. So we're going to use an algebraic method to figure out then where exactly they do intersect. The first algebraic method that we're going to use is the substitution method, and you can see the steps here. I modified this just a little bit. We're going to solve the following system by substitution. Step 1 says solve one of the equations for one of the variables. So as I look and I analyze the variables here, I notice that they all have coefficients, different coefficients, but this one has 1. So probably the easiest thing to do, which I could solve for any of these, but is to solve this one for y, because all I have to do is subtract the 4x to the other side. So I have y equals negative 4x plus 5. Step 2 says substitute the resulting expression into the other equation to replace the variable. So here's the other equation. Notice that the other equation has a y in it, and we're going to substitute this expression for the y. So I have 2x, that stays the same, minus 3 times, I'm going to leave some room, equals 13. And in the parentheses, I'm going to substitute negative 4x plus 5 and solve for x. Notice I just have one variable, 1x. So 2x plus 12x minus 15 equals 13. And that's 14x equals 28. X is equal to 2. So now that gives me the first coordinate of the intersection point. I need to find the y coordinate. So I'm going to take this 2 and I'm going to substitute it back into one of the equations. Probably be just as easy to do this one. So I'm going to have negative 8 plus 5, which is negative 3. So the point of intersection for this system of equations, or the point where they intersect, would be at 2, negative 3. So this is a consistent because it has a solution, and independent because it has one solution. Okay, here's another example. So we're going to solve this by substitution. So I look at my two equations and I see what would be the easiest variable to solve. And I'm basically, first of all, looking for a coefficient of 1. And I have one here. If I don't, then I still can solve for it. It's just a little more difficult, but no biggie. All right, so I'm going to solve this bottom one for y. I'm going to substitute it back into the other equation. Now, I can't emphasize enough how important it is to substitute it into a different equation and not into itself. You know, it's kind of like, doesn't work, it's going to get a nonsensical answer. If you try to put it back in, it's going to say, where does that line intersect with itself? I mean, that doesn't even make sense. Okay, so I'm going to start back up here, and I'm going to put 3, and I'm substituting for y, negative 2x plus 9, minus 2x equals 11. Then I have negative 6x plus 27 minus 2x equals 11. Negative 8x equals minus 27 would be 16. Negative. And so x is going to equal, right, 2. Okay, so now that I have the first coordinate in my intersection, I'm going to plug that 2 back in for x and solve for y. So negative 2 times 2 plus 9, so that equals 5. So be very careful. The solution is the set of coordinates. It's not x equals 2, y equals 2. It is the point 2, 5. And if you think about this, this is where this is the point where the two lines intersect. Okay, just an algebraic method. Okay, when we did graphing, we did some of the graphing on our calculator. I wanted to show you how to solve a system of equations by completing a table. Okay, so the process, here's my equation, is to put each equation in slope-intercept form, put it in the calculator graph, adjust the window as needed, and instead of finding the intersection, go to the table and find the intersection point. Okay, so I would like for you to solve this system of equations right here that I've given you by either graphing. Well, actually, I'd like you to solve it by graphing to confirm it, but I'd also like you to solve it by substitution. So copy the problem down into your notebook and solve this equation, and I will see you in class.